Alright, welcome back. This is the South Dakota School of Mines and Technology homework solutions. Homework number 5, which is activity and activity coefficients. Problem number 2, and it's saying, so we're using the book, what is it? Engineering and Chemical Thermodynamics by Milo D. Korutsky. Pretty good thermo book. Alright. What we're doing is we're taking the examples from 7.1. So if I go to 7.1 really quickly, it says, so I'm taking these infinite dilution coefficients, so I have gamma 1 infinity is equal to 0.88, and gamma 2 infinity, which is equal to 0.86. Okay. We can delve into what those mean later, but essentially they mean that, at least at infinite dilution, at that concentration, the 1s like the 2s better than it likes itself. Same thing with the 2s. The 2s like themselves. The 2s like the 1s better than they like themselves, because it's less than 1. Okay, but it's saying using these, figure out my constants. Okay. So this thing gets a little messy because it's so big. Oh, for Wilson equation, yeah. So Wilson is this big thing. And do I normally get my, those are lambdas, do I normally get my lambda 1, 2, and my lambda 2, 1 from infinite dilution coefficients? No, they're actually, this is a theoretical model. And so those come from theoretical interactions. So like electronic and other interactions at the molecular level. Also, size plays a sex. So, if I'm either thinking of NRTL or Wilson, but I'm pretty sure Wilson accounts for the molar volume of each component as a pure system, and so those all come into play when it calculates these, not infinite dilution coefficients. However, I can solve for them from infinite dilution coefficients, maybe to get an idea of, hey, what is the interaction energies and such? Okay, and I'm sure that's partly how they did do it. I wouldn't doubt it anyways. In any case, it doesn't matter if it's Wilson, NRTL, or something I made up. The approach is still the same. Okay, so I want my constants, and so what I need to do is I need to find I need to basically find gamma 1, 2, and gamma 2, 1, because they're constant, based on, hey, when this is infinitely dilute. When is it infinitely dilute? Okay, well, natural log of gamma 1 goes to natural log of gamma 1 infinity as x1 goes to 0. As it becomes infinitely dilute, meaning there isn't any of it, these are the same. As a result, x2 will also change. Okay? It will also change. Okay? And so I don't leave my x2s as x2s. That one goes to 1 as a result. And so when I plug things in, and this is a minus, so, I guess I already had it right there. So minus natural log of 0 plus lambda 1, 2 times 1 minus x2 times lambda 2, 1 all over 1 plus lambda 2, 1 times 0 minus lambda 1, 2 over 0 plus lambda 1, 2 times 1. Clean that up a little, cause okay, now a lot of times these just go to A or B or something really simple. This actually doesn't go to something simple. This goes to something a little bit more complex, and so this simplifies down to minus natural log of lambda 1, 2. X2 is not x2. That's equal to 1. I was hoping that would just go to 0, but that goes to 1. Okay, so I have lambda 2, 1 over 1 plus 0, which is, lambda 2, 1. So minus lambda 2, 1 minus lambda 2, 1, 2 over 0 plus lambda 1, 2 times 1. Okay, so that's, basically minus 1, but that's, it's a minus, so it's plus 1. Okay, so when I'm all said and done, this is equal to 1 minus lambda 2, 1 minus natural log of 1, 2. Oh. Lambda 1, 2. And so something you can notice here, based on this notation, my lambdas can never be negative. Okay. Otherwise, they won't represent something real. Okay. I'll get an unreal number. Okay. So this is equal to natural log of gamma 1 infinity. Well, I need the other equation. Okay. So I basically do the math exactly the same way, but backwards. So let's do that. I'm going to erase this one. I don't need that anymore. Now I want natural log of gamma 2 goes to natural log of gamma 2 infinity as x2 goes to 0 and x1 goes to 1. Now right here I have natural log of gamma 1. Natural log of gamma 2, what you'll notice in any real activity model, or at least most activity models, there's a level of symmetry, okay? And so, if I make this 2, this becomes a 2, this becomes a 2, 1, and a 1. This becomes a 1, 2, this becomes a 2, 1, this becomes a 1, 1, 2, and a 2. And this becomes a 2, 2, 1, 2. Okay. And, oh yeah, in your book it is wrong. It is not that in your book. There is a typo on this one. Okay, but let me confirm that that's true. Let's see here. So I should have x2 plus a21 times x1. That's where the typo is. Minus, that's supposed to be a plus. Oops. Oh, that is a minus, because it was minus 1 times everything. Okay, so that is right, and so that's still right. That's still right. Okay. Let's see here. A1, lambda 1, 2 over x1 plus lambda 1, 2, x2 minus lambda 2, 1 over x2 plus lambda 2, 1, x1. Alright. Plug those in, and I essentially get the same thing. So, I get minus natural log of, actually I think I get exactly the same thing except for the coefficients I use. So that still becomes 0 plus a21 times 1, okay, minus, that's an x1, minus 1, lambda 1, 2 over 1 plus lambda 1, 2 times 0, minus lambda 2, 1 over 0 plus lambda 2, 1 times 1. Okay, and so when I'm said and done, natural log of gamma 2 infinity is equal to minus natural log of lambda 2, 1 minus, that's 1, plus, oh wait, no, that's not 1, that's lambda 2, 1. Lambda 1, 2. That's plus 1. Okay. And so that's still plus 1, and so when I rearrange it, I get 1 minus lambda 1, 2 minus natural log of 1, 2. Oh, lambda 1, 2. Yes, honey?
I wanted to try which was the pause button, and I did not.
You gotta wait, okay?
But I pressed the wrong
Okay,
button.
give me 5 minutes. Sorry about that, daughters. Alright, because I'm still not done, but I have 2 equations, 2 unknowns. Okay? And so I just need to do some. Now you can see there's really no way to quote unquote, I don't think there's any way to actually solve for one and plug it into the other, because you have these natural logs, and so I can't really use algebra to solve for these. So I have to use something like solver or some iterative method to solve for these. Okay, I'm not going to do that. Just, what you need to do is set this up in solver so that this one will equal the natural log of that guy, and this one will equal the natural log of that guy, and figure out what lambda 1, 2, and lambda 2 would need to be to make those equations satisfied.